Lepidochromy at the Natural History Museum, London, Butterfly Wings as a Printing Medium. This paper will give an outline of lepidochromy, the art of taking prints from butterflies and moths. Lepidochromy is a relatively unknown form of nature printing, which is itself a very under-researched area. Particular attention will be given to the lepidochromous prints of the Natural History Museum of London, which span a period of almost 180 years, from the early transfers of Moses Harris in the 1760s to the complex prints of G.W.O. Woodhouse in the 1940s. I examined several of these under a microscope to gain new insights into the printing techniques used, the first time these prints have ever been viewed at such close range. This led to the identification of the oldest known print by an English artist. It is hoped that through bringing the technique to the awareness of a wider audience, more prints can be identified and further research inspired. Nature printing includes any printing method in which a natural object acts as the printing matrix or is used to create one. Nature prints, particularly botanical, predate written culture by thousands of years. Early Australians left hand silhouettes on cave walls. Tahitian islanders printed ferns on bark cloth. Leonardo da Vinci's notebooks include a basil leaf print, while Benjamin Franklin used leaves from native trees to protect early United States currency from fraud. Lepidochromy is also a type of nature printing, but its techniques, reproducibility, and results differ greatly from those of botanical nature printers. The image shown here is not a painting or a photograph, nor is it an actual butterfly wing. Instead, it is a print composed of the thousands of tiny scales which lend colour to the wing by pigmentation, reflection, or refraction. One of the most astonishing things about lepidochromy in a world of endless copies and manifestations is that it simply can't be mass-produced. To understand how lepidochromy works and the techniques involved, it's worth knowing a little about butterfly anatomy. The taxonomic group Lepidoptera includes butterflies and moths whose wings are arranged in two pairs. These are described by entomologists as the forewing, close to the head, and the hindwing at the rear. Butterfly wing markings have evolved to aid functionality. When basking, the dorsal pattern signals to potential mates. When resting, the ventral design provides camouflage or warns off predators. Thus, the wing membrane often has different colours and patterns on each side. These colours and patterns are formed by scales. The perforated membrane of butterfly wings, transparent in many species, holds thousands of wing scales. Some scales are pigmented, others have light refracting substructures. If pigmented, the colour can be shifted easily with the scale from wing to gummed paper, leaving a reverse image of the scales in situ, a lepidochromous print. The iridescent haze of some species is produced by a phenomenon known as coherent scattering, in which wing scales refract, rather than reflect, light. The effect is also seen on the feathers of a peacock. Scales of this type are known as photonic structures and are often ridged on the upper and smooth on the lower side. Regardless of their structure or function, scales can only be transferred from the butterfly once, creating 8 prints at best, all of which were often used in a single composition. These variations are linked to the two main types of lepidochromous prints, single and double transfer. In a single transfer print, the scale is moved from the wing by gummed paper. Thus, any part of the scale shaped to refract light is left face down on the paper and hidden from view. When scales are transferred twice, that is, moved from butterfly to sheet 1, then from sheet 1 to sheet 2, their original orientation is restored. They will look on the paper as they did on the wing. This is described as a double transfer print. It is impossible to determine the orientation of the scales with the naked eye, only under a microscope, and to do so reveals whether the image is a single or double transfer. By examining prints from the NHM in this way, I use the scale orientation to identify printing techniques used by each artist. This helps us track the when, where, and how of the development of each type. In 1731, a shilling would buy The Art of Drawing and Painting by John Peel of London. Between guidance on smoothing leaves with a dog's tooth and taking rubbings of papier-mâché snuff boxes, Peel outlined the manner of making the impressions of any butterfly in a minute in all their colours. His single transfer method uses a sheet of white paper coated with gum arabic dissolved in water. Gum water such as this was to prove a constant in lepidochromy for almost 200 years. A butterfly is laid dorsal side up on the sheet and the body clipped away before the paper and wings are moved to a smooth board and covered with a second sheet. Pressure is applied with a trencher and weight or a screw press. An hour later, the paper is removed from pressure and opened. The membrane is lifted away, revealing a print of scales with all their beautiful colours marked distinctly. Peel's guide was republished many times, but it is for artists, not scientists. The first English naturalist to outline lepidocromy was the ornithologist and artist George Edwards. Like Peel, he saw the value of the prints as aesthetic rather than scientific. Edwards described taking single transfer prints by laying the clipped-off wings on ungummed paper. Thick gum water, with a drop of ox gall for each spoonful, is then spread over a thin white paper, twice the size of the specimen. The gummed paper is used to pick up the loose wings and then folded around them, rubbed with a smooth hard object, then peeled open to reveal a print from each of the 8 possible surfaces. The wing membrane, stripped of its scales, is discarded. The earliest lepidochromous prints at the Natural History Museum, and, at the time of writing, the earliest known by an English artist, are those of Moses Harris. Harris was an exceptionally talented painter of plants and insects and a respected entomologist. The page shown here includes 4 images of Vanessa atalanta, the red admiral butterfly, made no later than 1766. The album was held by the NHM for over 80 years before the current study identified 2 of the sketches as lepidochromous prints. The watercolours show 4 of the 8 wing surfaces as a composite, a technique still used by artists in entomological illustration. Something to note here is the difference in the blacks and reds of Harris's watercolours and his prints, all of which represent the same species, and this in a bound album where the pages are rarely exposed to light. Harris's materials and method remain undocumented, but given his interests, he's very likely to have read Edwards' work and perhaps even Peel's. Rather than pure art or pure science, these prints were reference material to ensure accuracy in scientific illustration. After I identified Harris's images as prints, I magnified them. 2 bands of scales are divided by a gap showing paper in place of a membrane. This confirms their image as a print, not a clipped-off wing. When magnified, the scale orientation suggests use of a double transfer technique. This conclusion is supported by the presence of paper fibres from a secondary sheet on top of the scales. Neither scales nor fibres are visible to the naked eye, but at ×50 magnification are startlingly clear. It is difficult to be certain whether lepidocromy originated in France, England, or elsewhere. John Peel's guidance was published in 1731, but it was not until 1777 that Lyonnese botanist and abbot François Rosier related the chance discovery of lepidocromy by one of his fellow clergymen. According to Rosier, the priest noticed a butterfly stuck to a recently varnished barometer, but rather than release it, he pinned it to the instrument. The next day its scales had transferred from wing to varnish, leaving a perfect reproduction of colour and form. The priest looked into reproducing this and printing from it. In 1821, French entomologist Jean-Baptiste Godard described lepidocromy. Godard's adhesive was made by sifting candy sugar and gum arabic through a sieve of horsehair into a jam jar of water, a technique sourced from Louis de Fresnay, a taxidermist and curator at the Musée d'Histoire Naturelle. Godard is the only writer to gum the wing rather than the paper, which risks dislodging the scales but leaves the final printing surface free of any sticky residue. Around this time, a young Englishwoman, Elizabeth Davy, was producing these prints, now in the NHM. Vanessa Io, the peacock butterfly, is shown here with its larvae and food plant. Little is known of Davy's life, but these prints and the collecting notes which accompany them mark her not only as a talented artist, but as an informed entomologist. Unfortunately, the larger size of this volume, a folio, does not lend itself to being examined under a microscope, and her technique and method remain unidentified. In the late 19th century, the slightly eccentric Guide to Nature Printing Butterflies and Moths was published by an author known only as AMC. Over 140 years later, its author remains unverified. AMC uses a half sheet of unglazed paper and a daub, a firm leather-covered pad of cotton wool reminiscent of the printer's ink ball. The unglazed paper is folded in the middle, reopened, and gummed until tacky. Like George Edwards in 1747, AMC clips the wings from the body before laying them on one half of the gummed paper and folding it over. The folded paper is pressed with the daub, then moved to a smooth surface. The author recommends a marble table. It is rubbed with an object such as a crystal ball, an ivory paper knife, or, in emergencies, the bowl of a silver spoon. When the paper takes on a glazed appearance, it is peeled open, revealing a mirror image print. My entomological colleagues tell me AMC knew little of butterfly anatomy, but they, AMC, are the first English nature printer to describe methods using wax, rice water, egg white, and varnish as substitutes for gum water. They also state the art as having its origins with French missionaries in India. During my research, I also backdated another collection by around 30 years. William Francis Badgley spent many years at the Survey of India in Shillong, the administrative capital of Assam under British rule. Badgley presented the NHM with his insect collections and 3 notebooks of prints and sketches. For over a century, the notebooks were listed under their acquisition date of 1906. Watermarks examined for the first time during current research date 2 of the volumes as 1868 and 1872, with the 3rd notebook contemporary but unmarked. Dating by paper is not infallible, but if correct, this sets the collection almost 2 decades ahead of AMC's published guidance. A bas-relief impression of wing veins on the verso of each page reveals the prints were made directly into each notebook. These prints were aesthetically appealing, but they are also working reference tools in lieu of a pinned collection. In the late 19th century, lepidocromy, like botanical nature printing, was at its peak. In France, research was being conducted, shared, and discussed. The naturalist Charles Sarizien published La Lepidocromy and was selling prints at 25 francs per 100. Many of these are now held in the NHM. Further evidence of lepidocromy's appeal to the gentleman entomologist is found in collections from the Moldavian aristocrat Prince Aristide Coraja, made around 1885, although it is not known whether Coraja was the artist or just the collector. There are very few published books to include lepidocromy, due not least to the effort required to make original prints for every copy. As the 19th century turned into the 20th, the most ambitious such work appeared. Shermanfoot Dentons, as nature shows them, moths and butterflies of the United States east of the Rocky Mountains. In the 21st century, using over 50,000 Lepidoptera to make a coffee table book is unthinkable, yet in 1900 Denton did just that. The American author made the transfers for all 500 copies himself, producing books described by the Los Angeles Herald as, without doubt, the most extraordinary handwork ever done in the illustrations of a book of nature. It was an ambitious project and an expensive one, with a 2-volume set to be had for £24, around £1,900 today. Only 50 of these sets were available in the United Kingdom, and 2 of those are now held in the Natural History Museum. The eye-catching binding of one set, with gilded edges and Lepidoptera-themed corner pieces, actually seems a little understated, given its content. This is the only published work of lepidocromy held by the museum, and it is far outnumbered by the prints found in NHM manuscript collections. It is in reviews for Denton's work that a certain sense of distaste for lepidocromy begins to appear. As one reviewer stated, here is ingenuity indeed, but we hope it will not have too many imitators. After all, there are not too many butterflies. The penultimate collection to be examined here is that of William Harry Evans. While serving with the Royal Engineers in India, Evans rarely stopped collecting, taking Lepidoptera in Jabalpur, Simla, and Darjeeling, to name but a few. His papers reveal that he valued his prints for their relative stability. Gum scales stay fixed in a pattern longer than those on an increasingly brittle wing. 3 of the print collections discussed today were presented by English civil servants with ties to India, yet one only needs to head to the museum's entomology department for evidence that specimen collections far outnumber those of prints. Evans' prints are among the finest held by the Natural History Museum and use a double transfer process, like that of Moses Harris, to capture the iridescence of species, such as this great eggfly butterfly, Hyperlimnus bolina. The first half of the 20th century brought a sharp decline in the popularity of butterfly prints, but in 1942, L.G.O. Woodhouse, later Surveyor General of Ceylon, was making prints from butterflies, having captured almost all 242 indigenous species in 5 years. To the naked eye, Woodhouse's 187 prints are so well executed they appear to be intact wings. He clearly had a very steady hand, as an inked outline and the edge of the original paper can only be seen under magnification. Woodhouse used a process he described as wax cum gum, which he urged first the museum and then the British government to patent. Both declined. Woodhouse supplemented the printer's basic kit of paper, specimen, and gum water with an iron letterpress, waxed paper, and blotting paper. The clipped-off wings were placed on a sheet of waxed paper, then folded in the blotting paper and put in the iron press. The press is tightened to its highest setting before the papers are removed, rubbed both sides, and repressed. When peeled apart, the scales are set in the wax and the wing membrane is loose. As can be seen by this print of Azanus albardus, Woodhouse's technique was effective in reproducing the shimmer of light refracting scales. Museum archives include correspondence alleging Woodhouse has appropriated his method from an unknown printer. The situation was never resolved, and Woodhouse's teacher remains anonymous. It is unlikely Woodhouse met his butterfly printing predecessor, William Francis Badgley, but they both spent time in Shillong, India. It seems likely they both learned about lepidocromy here rather than in England. In conclusion, lepidochromous prints were accurate, beautiful, and often easy to produce. The basic combination of gum water, paper, and pressure, described by Peel in 1731, was continually refined but never entirely abandoned. As the 20th century progressed, the popularity of lepidocromy declined. Perhaps most thought-provoking is to question why these prints enjoyed the success they did. Lepidocromy was at its most popular in the late 19th century, by which time scientific illustration was highly detailed and photography well established. Intact specimens were really quite portable. The scientific value of these prints was negligible. Instead, it seems the value of the prints lies in their borrowed beauty, as the designs of nature become the work of a secondary artist. There is much scope for further research on this technique. The first is establishing a vocabulary. I've opted for lepidocromy and lepidochromous prints, as several 19th and 20th century collections at the museum use this terminology, and it appears frequently enough in the literature to retrieve results. Having never heard it said aloud, I mimic the pronunciation of Lepidoptera, the order to which butterflies belong. However, the literature also reveals common usage of terms such as lepidochromies, butterfly prints, and wing transfers in English, with equivalent and variant terms in many other languages. As many bibliographers know only too well, a small sample size can lead the scholar to draw wildly erroneous conclusions about the history and evolution of a particular technique. Given the NHM's collecting scope, these prints cannot be considered representative of lepidocromy as a whole. The more collections we know of, the more realistic our grasp of their context. The NHM examples, and another in the Smithsonian, show the technique was popular among British soldiers serving in India. Where did servicemen such as Evans and Woodhouse learn the technique, and why did they go to the trouble of making prints when most of their fellow entomologists were content with whole specimens? Even to a non-conservator, ensuring the stability of these prints appears challenging. Does aging gum arabic damage paper? Can loose scales be reaffixed? Will the print attract other insects? I look forward to seeing your research. In late 2020, thanks to a Rare Books mailing list, I was able to establish connections with a very small handful of other researchers with an interest in lepidocromy. These interested parties have a wide geographic spread, which bodes well for exploring the technique beyond Europe. A PhD is currently being written on the early 20th century prints of the Japanese entomologist Yasushi Nawa. In 2021, I hope to convert this interest into a website to use as a hub for collaborative working. There is a lot more current research than I'd realised, and as collections come to light, I hope to link these together. As one researcher working in one institution, my conclusions, like my vocabulary, are based on a small sample of primary resource material. I've attempted in this paper to make definitive statements about the technique where possible, but I look forward to, indeed encourage, having my ideas challenged as new collections and research come to my attention. Thank you.